1.1.3, 3x to the power 2, y to the power 3 multiplied by 4x, y to the power 2. Here we have a product. Remember that everything that's happening here, it is part of a product. Nothing is being added or subtracted here. Nothing is being divided. It is all being multiplied. So if I could just take this, and if I had to expand this, then all of this that you see over here can be expanded and written as 3 times x times x times y times y times y times the 4 times the x times the y times the y. So here is evidence and proof that the only thing that's happening here is multiplication. This is one big product. And I can, because of my commutative property, I am able to multiply how I want to, basically. I can multiply, even though the 3 and the 4 are far apart, they are separated, and not really separated because we've learned in algebra that the only things that separate numbers and terms are plus and minus. So the 3 and the 4 are not really separated, they can be moved around. So I can then say, well, I want to multiply all my numbers, and the only numbers that are here is the 3 and the 4. So I'm going to say, okay, 3 times 4 is 12. So the numbers are multiplied. Then if I look at how many x's do I have here? I've got 1, 2, and there's another one, there's 3. So I have a total of x to the power 3. And then in terms of the y's, I've got 1, 2, 3, 4, and 5. So that's y to the power 5. So just remember, we are counting the y's, but obviously we are adding the exponents. So it is 5 y's, so it's 1 plus 1 plus 1 plus up to 5. So we have y to the power 5. 1.1.4, again another fraction, and our numerator looks quite busy this time. And it may look that way because of the brackets. We sometimes get a bit intimidated with the brackets, but I want to just point out here that we are still simply just multiplying. In other words, the one bracket is being multiplied with the other one. And between the factors in each product, because what we have in the brackets are products, so that's a product, that is a product, and that means the only thing that's happening throughout this numerator is multiplication. The negative sign in front of the 4 simply means that the 4 is negative. We are not subtracting over here. And then in our denominator, we have one product squished together. In other words, the 10, the a squared, the b squared are all together, kept together by multiplication signs. So that is already simplified in itself for now. We can then just look at our numerator quickly. And in our numerator, once again, remember I said that you need to assess or look at, can I do something here? Can I simplify that further? And in this case, the answer is yes. In here, can I do something further? Well, in the denominator itself, we cannot do anything yet. So the answer is no, I can't simplify that further. But if I simplify my numerator, I can then maybe divide with the denominator once I'm done there. So the numerator, I've got 5a to the power 3b, and that is in a bracket multiplied with negative 4ab to the power 5. So once again, like we've done here in 1.1.3, we can, if we wanted to, we can sort of pull those things apart and then see the different factors, but we won't do that in this example. We'll simply just multiply out what we can multiply. So the 5 and the negative 4, we can multiply as becoming negative 20. So 5 times negative 4 is negative 20. The big mistake that a lot of you make here is you forget the negative sign. So you would write an answer of 20 and forget that there was a negative 4. So a negative times a positive gives us a negative. Then our powers, in terms of the variables, we've got a to the power 3 and a to the power 1. remember I said that we can then just, wherever I see a variable that does not have a power or an exponent, I will then just maybe put a 1 there just to see it. Maybe I should use red. So I'm just putting a 1 there. So that's a to the power 1. So when I multiply the a's, I've got I can keep my a as my base and add my 3 plus 1, so that is 4. And then for b, I've got then a 1 here as well, that's b to the power 1. And then if I keep my b and add my exponents, I've got 1 plus 5, which is 6. And this is all divided by 10 a to the power 2, b to the power 2. Now, once again, I will keep on reminding you of this and mentioning it over and over. A lot of you stop here and then you move on, but you are not finished yet. You still need to divide. So can I divide negative 20 by 10? Yes, I can, because negative 20 by 10 gives me 2. Now, please, I've noticed a lot of mistakes being made with these divisions. So please just use your calculator if you're uncertain, because sometimes you think that this must be a fraction, so then some of you write like 1 over 2 or negative 1 over 2 and all kinds of weird stuff. So please just take your calculator and say negative 20. Sorry, that's not negative 20. Where's my minus sign here? Negative. Okay, what's going on? Oh, there we go. Negative 20 divided by 10 gives you negative 2. So you know that your answer is negative 2. It is not a half. So when you write your answer, you would then say, okay, this is negative 2. And then for my a's, my powers with a, I've got a to the power 4 divided by a to the power 2. So over there. So I know that I can keep my base, and I'm dividing now, so my exponents must be subtracted. So it's 4 minus 2. And then for my b's, I can keep my b and subtract my exponents. Simplify, that would then just be negative 2, a to the power 2, b to the power 4. And that will be my final answer.